So, about a year ago, a friend sent me these comics, and it's about this developer. He writes a feature, and he wants to release it, like a beautiful butterfly, rising from stage into production to serve clients, but bam, there comes the QA with a bug, and all the happiness is gone. My goal in this lecture is to help this developer to keep on smiling. I present techniques and tips and states of mind that can help you to debug faster, better, and to be predictable, so you will know exactly what your next step is at every point of the way. By the way, hi, my name is Ella Shir. I'm a software engineer. I'm in love with software architecture, and I have this tech blog called Shir Engineer. You are welcome to check it out. My current job is writing real-time multimedia systems, where a bug can be the video is all colored green, there are no errors in the log, the system looks great. Where do I start? And at this point, I realized that we don't talk enough about debugging. I didn't learn debug skills in my computer science degree, and in the industry, I spent a lot of time learning Python, which I love, and other technologies, and maybe reading about clean code or seeing lectures about the design patterns. But I didn't invest time in solving problem skills, and I think that we should do this. We should get better at problem solving. And I have three different motivations why we should get better at debugging. The first one is don't bring me down. Sometimes we have negative feelings related to being assigned a bug. Maybe we feel guilty that we created a bug in the first place. Maybe we don't like solving problems and we feel that we are not very good at it. And that instead of solving a bug, I would prefer to write a new feature. So the first motivation is to get rid of the negative feelings that surround this issue. The second motivation is just get the job done. I want to do the assignment to solve the bug and do it as fast as I can and as efficiently as I can. And through this lecture, I will talk about different success criteria that we may have to the definition of done. The third motivation is about becoming a pro, because I want to get better at what I do. I want to be a better developer, a better engineer, and I can use bugs as an excuse to get better at my abilities and to sharpen my different skills. And I will give you some tips about this as well. What is the life cycle of the bug? So first of all, we observe a problem. This can happen at different stages of the development. Sometimes it's by QA or by a client in production, but it can also happen when I write new code and I try to run it, and I understand that something is not right. From this point on, I'm debugging. So after we saw that we have a problem, we want to find it. And we usually do so by gathering information or trying different things to understand where the problem is. So we go back and forth trying to gather information and find the problem. After we finally find it, we fix it, test it, and then we create more bugs. And it's an important statement because we need to understand that creating bugs is part of creating. We develop and we are not perfect, so we make mistakes, and this is okay. We should not feel anxious or guilty about it. Let's discuss more the part where we observe a bug. And for this, I have my imaginary friend, Sam. Sam is a developer. We have conversations mostly in my head because the bug that QA found was that the GUI showed 200% of upload. Do you know how to fix the bug? What you should do now? And Sam started to think about it in my head. The only real solution that I had to tell Sam is that we should stop guessing. When we approach a new bug, we should have a clear definition of the problem, what exactly we should solve. And usually using a list of steps to reproduce will help us very much in this part, because there may be other bugs in the same code, in the same area of the code, but we don't want to touch them right now. These kind of things can make us dwell and get lost very easily. The other thing that we should have is a clear criteria for success. What should I do in order to finish this mission? Like in the 200% GUI problem, it feels that the product team should help us to define what should happen in this case, because the feature is not exactly defined at this part. Another problem, for example, can be that the system doesn't load fast enough. So I have clear steps to reproduce. I restart and I check how long will it take the system to load. But what is my success criteria? How much time is it enough for the system to load in? How do I know it? These questions may seem trivial, but they actually help us to prevent from getting lost, because sometimes we rush too fast into the bug itself because maybe we know exactly where the problem is, but we didn't stop and define the success criteria. And then we end up having the client or the product team not happy with the solution, and the bugs get back to us. So this is important to do in order to prevent frustration of ourselves and everyone around us as well. Look at it this way. If the problem and the success criteria are very clear, it shouldn't take long for you to define them, and then you can move on. But if they are not clear, so you definitely should invest the time in making this clear, not just for you, but everybody else you work with. I want to tell you another story. This time it's mine and it really happened. I was dealing with a time-seeking thinking package, specifically replacing one called the NTP to another one called PTP on a Linux-based server. After writing some code and replacing the library, I had a bug. And it goes like this. Disconnecting and then reconnecting the LAN cable caused a time jump on the machine. It kind of made sense because it was related to the packages that I was replacing. And I had clear steps to reproduce. I know exactly what to do. And I jumped into the debug process. I would write some code, deploy, and go to the laboratory where the machine was. I would disconnect and then reconnect the LAN cable and run back to my PC to see the system logs and keep on debugging. It didn't solve the problem on the first try, so I added more logs and I checked more things. Then again, I had to run to the lab, disconnect and reconnect the LAN cable, and run back to my PC to keep on the debug. And so it went on and on and on and on. And I hope that you feel me when I say that I was quite annoyed. Not because I was too lazy to get up and go, but because all this running around in circles really chopped off my train of thoughts, and I was out of focus. And each time that I had to go and I went back and I got confused about what step was I trying, or what log did I add, or what should I be looking for right now. So I obviously wanted this cycle of running to be shorter. And my first idea was to bring my laptop to the laboratory with me so I wouldn't have to go back to my PC all the time. It was okay, but was there a more technological solution for this issue? So I said, let's Google it. One of the very first results in Google about this simulating the issue of reconnecting a LAN cable, I stumbled upon this script. IP-link set ETH0 down, sleep sometime, and then IP-link set ETH0 up. That's it. It was this simple, and I no longer had to run anywhere. What I actually did in this story is to create a faster debug cycle. A debug cycle is the time passing from having an idea or even wanting to add some print or see some variable state in the system to actually seeing the result. It includes the code you have to write, build, deploy, run, reproduce the scenario, and observe the bug. We compromise because looking for a solution, looking for a shortcut that will help us to reduce this time also takes us time. And while I Google a script that will help me to simulate the problem or not to spend 5 minutes on deploying, I feel like all this searching and Googling isn't helping me to solve the bug. It's just for my own personal comfort. It's not for the bug solving. So maybe I shouldn't waste time on this. When I shorten the debug cycle, I reduce the cost of an attempt. Each debug cycle is an attempt to solve the problem or gather more information about the problem. And if this time is very long and I get lost in the art of the debug cycle itself in reproducing the problem and everything around it. But if the cycle is short, I can build my logic and move on with my own thoughts and not to dwell on the logistics around it. I'm busy at the real thing that I should be doing. When the debug cycle is short, I can allow myself to take one or two wrong directions because it's not a big thing. The time I invested in it was very short. I can allow myself to be creative and go thinking out of the box or try things that I don't really think are the problem, but I just want to know that the problem is definitely not in this part. So I gain certainty and I can allow myself to do this if the attempt doesn't cost me much. So just before fixing the problem, we stumble upon a difficulty. And there are all kinds of stress that we need to close this bag as fast as we can and to move on. But this is a risky part because it may also create a technical debt. So when we approach to actually fix the bug, we have to keep in mind the same principle that guide us when we develop a new feature. Things like object-oriented programming, solid principles, clean code, doing design review, and generally choosing the right technical solution for the problem. So we chose a solution between a couple of options, and we implemented it. My last tip is about creating more bugs. Well, it is my last tip, but it's not about creating more bugs because I think that we are all going to do it anyways, and it's completely okay because it's just a natural part of writing new code. One of the ways to become a great developer is to learn new tools and to improve constantly. It can be learning new debuggers, of course, because we are talking about bugs, but more than that, it's a chance to write a Python script if you're not a Pythonist. It's a chance to write a shell script if you're not familiar with it. If I did all my bugs as fast as I could, but I didn't learn anything new, so my 99 bug will take just as long as my first because there was no progress that I made. And this investing of time is exactly what is going to make you really great at what you do. The three motivations that we started our journey with were to gain skills and knowledge that will stop bugs from bringing us down, skills that will get our job done and that will help us to become pros. I hope that this session got you a bit more enthusiastic about the art of debugging. And if you're interested, you can check out my blog that has some more great tips about what great developers do when they debug. Thank you for being with me, and goodbye.